Hello, grade 12s. This is the most recent video that corresponds with lesson 2 of the second half of the semester. What we're going to cover today is permutations and how they can be used to solve real world problems, both where there's no repeats and then also where there are repeats. And that'll make more sense as you go through the lesson. At the very end, there's a section where it's basically what would have been a thinking question. Because we're doing the major project, it's going to be a ton of communication and thinking. We'll be focusing mostly on knowledge application, so you won't have to deal with some of those more difficult thinking questions. But I'm going to cover it anyways, just for your interest's sake, so you know what's there. But again, it won't be on any assessment. So, all right, let's get going. Okay, so permutations, organized counting, part C, permutations. So let's get going here. Permutation is an arrangement of objects in a definite order. So as long as they have order, so first place, second place, third place, then you can use permutation. It's a different situation if there's no order. For example, I need a group of 3. Well, a group of 3 has no order. There's 3 people, they're all equal. There's no order, no first, second, and third. So that would not be permutation. But if I needed first, second, and third, that's permutation. So let's take a look at some examples. First one, how many permutations are there of the word uniform? So count the number of letters. 1, 2, 3, 4, 5, 6, 7. Okay, in position 1, there's 7 options. Position 2, there would be 6 options. 5, 4, 3, 2, 1, or 7 factorial. So 7 distinct letters, 7 factorial. Each of the spaces has one less option because you've used a letter. So in position 1, there's 7 letters. Okay, 7. You take away 1, you get 6. So position 2, there's 6. Take away 1, there's 5 left, etc. Easy way to do it, 7 factorial, should be in your calculator. That was yesterday. 7p7 is what we want to move towards. So there's 7 options and you need 7 of them in order. 7p7. We'll get to some more examples in a second here. How many ways could a president and a vice president be chosen from a group of 8 nominees? So if there's 8 people, who's going to be president? Well, you have 8 options. Who's vice president? You have 7 options. 8 times 7. Now, another way of doing that, and it isn't really helpful with 2, but as you get to more positions, it becomes helpful. You could do 8p2. So rewrite your answer above in terms of factorials. That's 8 factorial, because there's 8 people. But you don't need anybody past 7. So 8 factorial divided by 6 factorial is going to get rid of everything. 8 factorial divided by 6 factorial. And then the other way of writing this is 8p2. There's 8 people, you need 2 in order. How many different 3-digit numbers can be made from the digits 2, 3, 4, 5, 6, 7, 8 if there are no repetitions of the numbers? So first of all, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7 options in position 1, 6 options, 5 options. Multiply them together, you get your solution, or 7p3. In terms of factorials, 7 factorial divided by, you don't need anything past 5, so divide by 4 factorial. If you have n objects and want to arrange them r at a time using factorials, that's n factorial divided by n minus r factorial. So n objects, in this case it was numbers. You had 7 numbers, and you want to arrange them 3 at a time. So it ends up being 7 factorial divided by 7 minus 3 is 4 factorial. And that's how you'd solve that. The other way, again, is the P button, which we're going to get to. So here's the breakdown. This is really important. You need to understand this relationship. N is the number of objects that you're looking at. If they're in order, then you're using the letter P. And then how many of them you want in order is R. So N is the total number available. R is how many you actually want. And they have to have a definite order. In a card game, each player is dealt a face-down hand of 13 cards that can be turned up and used one by one during a game. How many different sequences of cards could a player have? So, how many cards are in a deck? There's 52 cards in a deck. You need 13 of them. So you could do 52 times 51, and you just do that 13 times. Or 52 factorial divided by 52 minus 13 factorial. Or use P, 52 P13. It's the same thing. And obviously it's the quickest way. P should be in your calculator, 52 P13. Evaluate 5P5 using factorials. You have 5 people, for example, and you need to put them in order. You need all 5 of them. Now take a look at that denominator, 5 minus 5 factorial. That is equal to 0 factorial. What is our rule in mathematics? You cannot divide by 0. So 0 factorial has to equal 1. 0 factorial must equal 1. There's only one way to have 0 things arranged in order. Essentially, that's the way to look at it. 0 factorial is 1. If you don't have anything, there's only one way of having that situation, where you have nothing. All right, exercises, page 80, 1 to 10, 14 to 16. Again, if you have any questions on your homework, just post on the discussion board. And then if I have to make videos for solutions, I don't mind doing that. Otherwise, we can have discussions. You can expect an assessment next week. So we'll do a review and an assessment next week. Here we go. Permutations with similar objects. What happens when there's a repeat? So before it was 7 different numbers, no repeats. What happens if there's a repeat? So let's get into that right now. You can generalize this example to show that of the number of permutations of a set of n items, a are identical, you get n factorial a factorial. Michelle's covering the top of an old end table with ceramic tiles. How many patterns can she make if she uses 4 yellow tiles and 1 blue, 1 green, 1 red, and 1 gray tile? So total number of tiles available is 4 plus 1, 2, 3, 4. So there's actually 8. The 4 yellow plus the 4 other ones. 8 total. But she has a repeat of 4 yellow tiles, so you need to get rid of those 4 repeats because they're going to, because order, when you have a yellow first, doesn't matter which yellow's first, it's a repeat. Same thing, you can't have a different, can't count it as a different permutation if the same thing is first and the same thing is second. That's the same thing. So essentially, you got to get rid of the double counting of the 4 yellow tiles, and this is how you do it. 8 factorial divided by 4 factorial. Because there's 4 yellow tiles. If there was 6 yellow tiles, it would be 8 factorial divided by 6 factorial. assuming that there was 6 yellow tiles and then 1 each of the other types. Let's get some other examples going. How many permutations of the letter bookkeeper? All right, count the letters in bookkeeper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 factorial in the numerator. In the denominator, we need repeats. How many O's are there? 2. So that's 2 factorial. How many E's are there? 3. So that's 3 factorial. How many K's are there? 2. That's 2 factorial. So 10 factorial divided by 2 factorial, 2 factorial, 3 factorial. Because of the repeats in O, in E, and in K. And there's your solution. All right, so permutations with identical objects. The number of objects is n factorial divided by its repeats, however many different repeats you have. This is the example I was telling you about. This is going to be a more complicated thinking type question. You're not responsible for this, but it might help you with your understanding. So how many 7-digit even numbers less than 3 million can be formed using the following digits? 1, 2, 2, 3, 5, 5, and 6. So they have to be even numbers. To be an even number, your last digit must be a 2 or a 6 because those are the only even numbers. And then to be less than 3 million, you need 1 or a 2 going first. So the scenario, if you start with a 1, is different than the scenario if you start with a 2 because of those repeats in the 2's. So it's going to change the situation. And if you end with a 6, that's different than ending with a 2. So that changes the situation. So the easiest way to do this is to break it down into scenarios. If I start with blank, so start with 1, end with 2, or start with 1, end with 6. Give you a second to think your way through that. Again, remember the number of digits. You have 1, 2, 2, 3, 5, 5, and 6. 7 digits total. You need a millions digit. Starts with a 1. There's only one way of doing that. Ends with a 2. Only one way of ending with a 2. In between, you have 2, 3, 5, 5, and 6.